Hello, everyone, and thank you for joining today's live event. Today's topic will be covering video borescope small diameter probes. So we'll be talking about inspections and applications for probes that are less than looks like I might have lost the PowerPoint here. So let's see. I can see mine. Okay, I think we're gonna. Okay, good deal. We're back. Sorry about that. So here's our high-level agenda for the day. Some technical difficulties, but we're back on track here. So we're going to start off with a quick intro to small diameter probes. We'll talk about some of the industries that these small diameter probes are used in. Then I'll go through 4 or 5 specific applications, and then we'll talk about the solution. The end of the presentation here. Okay, so let's jump into some of the industries. Before I touch on the industries that these probes are used in, I should mention that when it comes to remote visual inspection and video borescope inspections, traditionally technicians had a choice, from 4 millimeters in diameter, 6.1 millimeters, and 8.4 were kind of the core diameters of choice for video borescopes. But if they had an inspection that required a probe of less than 4 millimeters, they were forced to use a fiber scope, and that's really is recording videos, creating reports. So with the advancement of CMOS imaging technology and that going into smaller and smaller packages, there are now some very, very small diameter video borescopes that folks can take advantage of and take advantage of the other technology offerings there. So as far as the industries, so aerospace, aviation, there are turbine inspections where folks can't reach with a 4 millimeter. Also, there's a bunch of miscellaneous tubing, fuel tubing, hydraulic tubing that needs to be inspected, finishing, welding that needs to be inspected at the OEM site. Same with power generation. So there are turbine inspections where you need to use a smaller than 4 millimeter diameter probe, as well as tubing inspections. In manufacturing, it's very common to see these devices used to look at castings. These castings have a lot of small crevices and tight bends where you have to get in to look for blockages or burrs. There's also cracks, drilling holes that you have to go look into. Also in manufacturing, there's motors on site where there's a specific application where you have to look for in between the stator and the rotor to look for a gap to maximize efficiency of that motor. So we'll take you through that application here in a few slides. And then with automotive, very similar to manufacturing, right? It is manufacturing in automotive. So you're looking at castings as well of the engine block, looking for similar types of defects like burrs or blockages. Finishing, welding, grinding, machining, drilling, all of these have tight spaces where you can't use a 4 millimeter. And then finally, the actual, car engine, there are some inspections that call for a small diameter probe. Okay, so let's move on, transition over to some specific applications. So I'll take you through. The first one is on aerospace. So typically aerospace engines, you're using a 4 millimeter and a 6 millimeter probe, but some inspections on these newer engines, such as the CFM LEAP, recently operators have been faced with a service bulletin requiring them to do a 360-degree inspection below the compressor inner shroud, and they have to navigate between the stator shroud and the rotor and get down below there to perform this one-time inspection per the service bulletin to look at this critical area. So it's important that they have a less than 4 millimeter diameter probe and a 2.2 millimeter to get in there and look at this critical area. It should also be said that there's other applications on the LEAP engine using a 2.2 millimeter by 1.5 meter probe. less often, but when there's removal of the fan core module, they have to observe that using the 2.2 millimeter. So we'll move on. We'll talk about another aviation application. So this is on a pitot tube. And if you're not familiar with that, that's a device that's mounted on the exterior of the aircraft that measures the speed of the aircraft by measuring the total pressure of the airflow around the plane. And so you can see a picture of that on the left side, that very small hole. That needs to be inspected. And what happens is these engines oftentimes need to be taken and put into storage. Depending on where in the world that engine's in storage, if it's a clean environment, could be in a desert. During dry storage, when they take it out of storage to come back in operation, contaminants can settle into that pitot tube area. I've even heard insects, it can get in there. So you have to go in there and inspect that very small hole, make sure it's free of any contaminants so it's not impacting any of the readings that you're getting on that important sensor. So moving on to the next one, I think we have one on general industrial. So this one's on a new motor, just in an industrial setting, manufacturing. A lot of times there's these motors. This particular one is on a 250 horsepower motor. And the inspection that needs to happen is to look at a gap between the stator and the rotor to ensure minimum gap to maximize torque and, so it can pass the performance test for efficiency. So if you look on the left side here, this cutaway of the graphic, you see these, iron teeth that are around the circumference. Those are part of the stator. And then in the middle, you have the rotor, which rotates, of course. And there's a small gap we have circled there. And that gap, of course, you don't want any rubbing. You want adequate clearance, but you don't want too much clearance so you have efficiency and power with that motor. So technicians will go in. They'll inspect 3 or 4 different angles at 0 degrees, 90, 180, 270, just to make sure that rotor center and the gap is adequate clearance. So if you look at the borescope image here up top, you can see kind of the wide angle look where that gap is, and then the close-up view that was taken with a small diameter probe to make sure you have adequate clearance there. And these inspections will be done sometimes at new installation after the motor's transported, and also after it's bolted onto the seat frame. The probe of choice for this is a 2.2 millimeter by 1 meter or 1.5 meters long. And some of the manufacturers of the motors might include Toshiba, Ebara, and ABB. Okay, so we'll move forward we have another aerospace application we'll talk to. So this one is more on a very popular engine, the CFM56-3. And you can see this video. Hopefully it's playing okay for you on the right side. And there's a lot of tubing on these engines, of course. So it could be fuel tubing, hydraulic tubing. In this particular inspection, they're looking for coking, which is unburnt fuel, or hot oil that hasn't drained. And so you get a nice, crisp, clear image. You can see that nice wide field of view, so you can see all sides of that tubing. And we'll go through how you connect this probe to the Everest Mentor Visual IQ Plus. And then one more application we'll talk to, also in aerospace. A lot of aerospace applications, not that that's the only place these probes are used. Can also be used in power generation. So we're looking at power or aero turbine blades, and they're looking in these cooling holes where you have that yellow circle, very small cooling hole, and they're inspecting for blocked air passages from leftover or retained casting media. And so during the casting process of the blade, if there's any of that casting media left in there, that's a problem that can cause issues down the road if it gets into the blade material during operation. So you need to go into that cooling hole and take a look to see if there's any blockages or any leftover media. So with that, why don't we transition over? We'll talk to a specific small diameter probe, the proposed solution. And so we'll start by going over the overall device. So this is the USB probe, we call it, from Waygate Technologies. As you can see, nice ergonomic handle. We have kind of the overview of all the features and buttons here. So one of our more popular features with our other video borescopes is the all-way articulation, of course, right? You have a joystick. You can do full 360-degree inspections, and it's very ergonomic. Number two, you have a powerful LED that's mounted in this, a light engine, so you could turn that on or off with the side switch there with your thumb. The illumination control, so you can turn up or down the brightness of the actual LED. And number 4, you can adjust the image brightness as well with number 4. And now these connect directly to the Everest Mentor Visual IQ Plus or the Everest Mentor Flex. And there's a cable, a LEMO cable that connects to the bottom of it. And then the other side uses a USB Type A to connect to the borescope. And then there's a hands-free holder at the bottom, a nice little base that you can use to mount this. So the diameters that are offered are 2.2 millimeters and 3.0 millimeters. The lengths are 1 meter, 1.5, and 2 meters. And then all new, just launching here, I think this week or next week, is a 2.2 millimeter diameter with all-way articulation. So with that 360-degree articulation, previously it was only 2 ways. So you had one of those old fiberscope type knobs to go 2 ways, but now you get that 360-degree, and you'll have that ergonomic joystick. Also new on the 2.2 millimeter is a side view, a dedicated side view 90-degree probe. So if you're getting those really tight applications where you don't have room to articulate over, you have a 90-degree dedicated probe so you can see, for example, the wall of a tubing. So we'll move ahead and we'll give you kind of an overview of how this works with the overall system. So we call these USB probes, of course, because they plug into the USB port of the Everest Mentor Visual IQ Plus and the Everest Mentor Flex. These are kind of the flagship products from Waygate Technologies. It is the only USB probe that will plug into these devices. You get nice, crisp, clear resolution on these large screens, so 1024 to 768 still in video image resolution. I think what I like best about it, though, is you get to leverage the capabilities of the video borescope. And so it's compatible with a lot of the features that you have on these Mentor products. For example, InspectionWorks Connect local video streaming. This is an on-device app on the Mentor products where it allows you to wirelessly stream video from the borescope to a tablet or phone. And so it works with iOS, it works with Android. And it's nice because you can stream video and have a nice ergonomic tablet that's lightweight, big screen, you can mount that. Or you can even control the device from the phone or tablet, remote control. Now you can't control the USB probe, but on our other probes, you can do articulation, measurements, anything you can do on the borescope, you can control with your phone or tablet, which is pretty cool. The other thing you can do with InspectionWorks Connect is transfer data wirelessly. So I can save images and videos, and I can transfer those over wirelessly from the borescope to the phone or tablet, and then I can email them, text them, whatever I have to do to communicate those. So that's one of the features you can take advantage of. The other one is menu-directed inspection, or MDI we call it for short. Menu-directed inspection is an on-device reporting software on both Mentor products, and really 2 main functions. One, it's going to automatically tag each image with where you were in the asset when you captured it. So if I'm inspecting stage 2 of the compressor, looking at the leading edge of a blade, it's going to tag the image with that rich data tag. So it's on screen and part of the metadata. And so when I upload that to the cloud, maybe it's InspectionWorks Insight, that rich data tag is there. So I can, trend that across different assets. The other thing menu-directed inspection does is it auto-generates reports. So rather than ad hoc create a report after your inspection in Word, which can be time-consuming, you just click Generate Report. It does a nice report for you in Word document or PDF format, and you have that ready to go. So that's MDI. I should mention that these USB probes also connect to most PCs. So you can plug it into a laptop and operate it that way. Now you don't get the functionality that you would, of course, with the Mentor Visual IQ Plus. But if you don't have one of those borescopes, you can also use this by plugging it into a PC. Also wanted to mention the variety of diameters and lengths now on the Mentor products. So it ranges, wide range for any application, really. 2.2 millimeters, 3 millimeters, 3.9, 4.0, 6.1. We have a 6.2 millimeter working channel probe that offers retrieval, and 8.4 millimeters for big piping inspections. And then the probe lengths ranging from 1 meters all the way up to 30 meters with a long steer probe. So huge variety of lengths. And if one of those lengths isn't there that you need, if you contact us, we actually make custom products. So we'll offer a custom length probe for you to fit your application. So with that, let's wrap up. That's all I had for today. We can go ahead and move on to questions. So if anybody had any questions, we'll take a look to see if there's anything in the chat. While we're checking that, I would recommend also you can visit our website at waygate-tech.com to look at our full portfolio of products, where we have our literature and manuals also posted there. So it does not look like we have any questions for today in the chat. So I'd like to thank you all for taking the time to join our live event today. We'll wrap up with that. Thanks and have a great day.